I just finished installing 3 Growatt brand inverters right behind me. Each inverter is 5,000 watts. That gives me a total of 15 kilowatts worth of inverting power. Wow, that's even more than my yellow inverters over here. So in this video, let's dive into how I wired them up, what I did, and what I'll be using them for. Here we go. Hi, I'm David. Welcome to my channel where I like to DIY renewable energy and energy efficiency projects. Now, I've been running my house for the last year on these yellow inverters, which are SMA Sunny Islands, and they work, but they are expensive. I got them at a discount when I bought them a year ago. So I wanted to try something that was available today, and that is these Growatt brand inverters. Now, what's neat about them is that they're putting out 240 volts, so you can parallel an odd number. Like what I have here is 3 of them. You don't have to parallel them in pairs like you do the yellow inverters. Each inverter is 5,000 watts. That gives me a total of 15 kilowatts worth of inverting power. Now that is a lot of inverting power. That will power the entire garage that we're in and the house. And it's going to power the whole thing, hopefully off-grid and hopefully no issues. If there are some issues, I'll be reporting them in an updated video after I've been running these for probably a month or so. So you can actually purchase these 3 Growatt brand inverters for about the same cost as one of these yellow inverters. That makes these Growatt brand inverters a really good deal. Now these inverters have built-in charge controllers, so they're going to be connected directly to the solar panels outside. In a previous video, I ran through how I got the solar wiring in here, and you can check out that previous video. A link will be in the description below if you want to see how I got the solar PV wiring into these inverters. Not all inverters do that. It used to be that you'd always buy them as 2 separate components, the charge controller and the inverter. These just happen to have both components built into one box. So I wired the solar PV array, one array into each inverter. Now the built-in charge controllers for these are higher voltage. They go up to 450 volts DC. So when I wired these in, I was able to wire more solar panels in one long string. That means that each array is coming in as only 2 strings. That keeps the wiring pretty small. This is actually the wiring for it. Now these 3 IMO disconnect switches, they can switch up to 1,000 volts, or I think there's even a setting on here for up to 1,500 volts, but you have to kind of derate it a little. But the point is that they're very high voltage disconnect switches. Now I'm running my PV in here more at about 300 volts. So these things can handle switching that off no problem. This is a pretty old screwdriver. It says number 30 on it. It's a Robertson, or also called a square drive. And this particular one I got from my grandfather's toolbox. And I wish I could have known him more. I don't have any memories of him. But I got his toolbox, I don't know, last year or year before, and I just kind of get a kick out of using some of the things. Any chance I get, it's just kind of nice. So I have 3 circuit breakers for the 3 inverters, each one running on its own. Out of the AC combiner box, right down here on the very bottom, I have 1 circuit breaker that is a 30 amp circuit breaker. It runs to the auto transformer. This is a 5,000 VA auto transformer from SolarEdge, and all of this stuff you can buy from Signature Solar. Now the auto transformer is what gives me my neutral, and that is fed into the neutral bar of this AC load center. Out from that, I then have 2 more circuit breakers to 2 different loads. One load is just a water heater here in the garage, and the other load is what is backfeeding through my transfer switch into the house and garage as a total property. Remember, all of this is off-grid, so the transfer switch will only power the property either on-grid or off-grid. never combined. None of this backfeeds the grid. I have three 50 amp circuit breakers. These are where the Growatt inverters are going to hook into. And then off here, I have a 30 amp, which goes to the water heater. That's just for a load, so I can load this down. Right here, I have a 50 amp, which is gonna go off to the house, and that's where this neutral is gonna go right here. So that 50 amp with 6 gauge wire neutral is gonna go off to the house through the transfer switch, and this 30 amp feeds the auto transformer, which comes back with the neutral. Now yes, this should be in conduit, but I need to test this whole setup before I go and buy all these fittings and conduits and everything else. I need to make sure that it actually works. This is a little meter I'm going to be using to measure the amount of power that the inverters are putting into the panel. So I have this little clamp. I'm going to clamp it around these 3 leads. Now these are all going into L1 of all 3 inverters. So that's clamped on. And now I'm going to use, next I'll just use a couple of these little guys to kind of help secure it to the wall, because I don't want it to go anywhere. This is a large 600 amp hour, just a little over 30 kilowatt hours worth of lithium iron phosphate batteries. I've done previous videos on this battery bank, and I'll leave links in the description below if you want to find out more information about the battery bank. Now inside this battery cabinet, there are large bus bars. These are copper bus bars with tin plating. I need to run battery cables to each of these inverters. The manual says to use at least 2 gauge wire. The ones that I have here, this is 1/0 wire, and I use this in my giant tower of power over there. So I've taken this off so that I can still use this Victron Smart Shunt to monitor the power going from the batteries into here, so we can keep looking at the efficiency of the total system. So I've taken out one of the cables because I had built this originally with 4. So we'll put this on top of the cabinet. I'll use some pieces of 4/0 wire to go from the shunt down into the bus bar that's built into it. Now this side, for the positive, I wouldn't actually need this box with bus bar. I could run these cables directly to the bus bars that are built in. There are 4 spots in here where you could screw to them. But since I have them built into the box, I'll just use them this way. So certainly if you were to do this better, I would recommend getting a metal wireway, which is what I've used for the SMA inverters, and then you can protect all these wires. A suggestion from one of the viewers was to replace these little rubber discs. The ones that are kind of in this battery box to start with, they tear very easily. So I ordered these ones from Amazon, and I'll leave a link in the description below. Hopefully they last a little bit longer. So now you can trace this, and it drops down into here, and I've already attached it using a screw. So now I'll do the same thing on the negative side, but the negative side is going to go into the Victron Smart Shunt. That way we'll be able to monitor it. Inside each of these Growatt inverters is a positive and negative post. Those are 10mm nuts. So I'm just going to take those off. So here's the positive, and it'll just go in here and get on the post. Just like that. And I'll just put the flange nut back on. And same deal with the negative wire, it'll just go in here on the negative post. And I'll tighten these down. And now it's just rinse and repeat. I have 3 positives and 3 negatives to connect up to these posts. Once I get them connected, I'll add on some of these little plastic hangers to help support the wire up so that we don't put stress on those posts, just in case I accidentally hit it. That is how I brought the battery to each inverter. Oh, and let me backtrack for just a sec. Before I could mount these inverters, I actually put up a 1/4 inch thick piece of cement backer board. This is a kind of a concrete board that you buy at your home center, and it's designed to be a tile backer. So you might put it in bathrooms and then put tile on it. Now the cement backer board can't burn, so that gives you that non-combustible surface. The outside steel casing of these inverters doesn't seem to actually get hot. The fans just run constantly, but at any point here I could put my hand on them, and the box itself doesn't get hot. But still, the manual says you need a cement backer board, so it's a good idea to follow the manual. Now each array is wired to 1 switch. I have 2 strings, but these are 4-pole switches. Now that means that I'm switching both the positive and the negative side of the array. Then each array goes through 1 switch and then to 1 inverter. So each array comes into the garage through underground conduit. Then it goes to 1 of the IMO switches. So 1 array to 1 switch. Then it goes to 1 of the inverters. Now right at the point of the inverter, the 2 strings are combined. So the 2 positives are combined into 1, and the 2 negatives are combined into 1. But there's only 1 negative terminal and 1 positive terminal inside the inverter. So right at the point where I was going to take those wires and put them inside this charge controller, I combined them using a ferrule. That takes the 2 wires and I crimp them together, and it makes one nice little terminal end that's crimped, and I can put that into the screw terminal of the inverter, tighten that screw down, and now I've combined the 2 strings. Ideally speaking, I would have liked to do this using some fuses and done the combination down at the fuse port, but I don't have the fuses in right now. I ordered them. When they come in the future, hopefully I can add them. But the code does allow for you to combine up to 2 strings without needing a fused system in it. So it's okay, but I still like the idea of adding fuses or circuit breakers. So I did order them and will be adding. The inverters then use the power from the PV, and they'll either power themselves, power the building, and any surplus they'll send down to the battery, which is right here. From the solar array to here, I'm using 12 gauge stranded THHN wire. So I'm just going to continue this off of these PV disconnects. So as of right now, I'm just going to take this wire and we're going to run it into here. I have 2 positives and 2 negatives coming to this PV disconnect from the solar array, but I only have 1 positive and 1 negative on the inverter for each one. That means that I need to do a combiner. Now, there's a lot of ways that I could do a combiner, but the simplest and fastest way is what I'm going to do here, because again, I need to just test that these can work with the whole house. After that, I can do a lot more with conduit and things like that. So let's just get our distance here. Let's say I'm going to go like that, come down a little bit. So that's our distance on the positive. We'll do 2 positives. And then we also need to do the same thing on the negatives. There's something interesting about these disconnects that I didn't know when I first wired up the one that is out at the solar array, and I had to go fix it. It turns out that the ports don't go straight through. They actually cross each other. There's like an X pattern, which I didn't know. So the port up here, called number 1, actually zigzags down here to number 2. Now, part of the way to tell is that it's stepped farthest back. So right here, see how this is stepped farthest back? It tags up with the one that's farthest back on the bottom. Okay, see the copper is right at the tip. Go. And now we'll just crimp this one down and get it in here.
There's a battery,
Okay. So now we've combined the 2 strings. So now I'll just do that same combination pattern over here on the 3rd Growatt, and then when the sun goes down, I'll do it on this one. We'll be able to turn everything on. It'll be fun. All 3 Growatt inverters have their covers on. Well, the load center is done being wired with the auto transformer and circuit breakers. They all flow into each of the Growatt inverters. I didn't have to go 2 or 4 or 6. I didn't have to move up in increments of 2. Now that is one of the benefits of using the 240 volt inverters. Now Growatt, as well as several other brands out there, such as the SMA brand, they make inverters that put out 120 volts only. And then if you want to combine them to create split phase for your house, you need them in pairs. So they'll be 120 and 120 out of phase of each other, so that it'll be 240 volts across both of them. Now that works fine, but when you need more than just the 2 inverters can put out, then you need to always jump up in pairs. Sometimes that doesn't work out to your benefit. And other times it just might not be a big deal at all. It just depends on your situation. The final step of wiring all 3 of these inverters is to parallel them. We need to parallel them with some kind of communication so that they will be in sync with each other. Otherwise, the sine waves might not match up. So we need to make sure that the sine waves match. In the manual on page 27, it shows a diagram of how to wire these. And each inverter came with a bag full of wire. So I need to follow the diagram here and jump from one to the next. Now, inside each inverter is a parallel board, a PCB or a printed circuit board, which is specific for paralleling these together. So if we look underneath, you can see the connection points. One of the wires to use is this, a gray one here. It reminds me of a really old-fashioned computer from when I would be growing up. I don't know what this is called, but it's a D shape, a D style, and it has pins on it. So it looks like on inverter number 1, the left comes over here and goes to the right side of inverter number 2. So let's try making that connection. Now I just have a little coil here of the wire, so I'll have to tuck this up and screw it to the wall to keep it in place. So that's the process. I'll just follow this diagram and go from one connection to the next down the line. I finished the wiring of all these inverters for all the parallel connections, and there's a lot of them. There's 2 grays and then these twisted pair of red and black for each. So it kind of looks like a mess now, and I wish that looked a little bit better than it does. Next step, I'm on page 32 and 33, and this is for the settings in here. So I'm setting all of them to PAL for parallel mode, and now we're going through the instructions, and it looks like this one is the master, and then these ones are slave 1 and slave 2. So I got to go through this manual and set it up. Now, once all of this wiring was complete, I then spent a lot of time double checking and triple checking all of my continuity. I wanted to make sure that I had L1 all hitting L1, L1, L1 across the board. All the L2s, so nothing was crossed. The auto transformer was there, and I had to turn on the auto transformer. After about 1 day of running, I did add a thermistor to the auto transformer, just so that I could watch on a screen what the temperature is inside the auto transformer. I've also added multiple monitors, which are over here, and what these will allow me to do is check what the total wattage is going into the load center, as well as how much is on L1, how much is on L2, and it's just additional ways that I'll be able to pull efficiency numbers while running these over time. Now I'm going through all these menus, and even though this is the master, it does not automatically control the menus in the rest of them. So now that I've got everything set up in this menu, I'm going through and checking the rest. So this is item number 5, and it says US2. So over here, US2 and US2. At this point, all of the menus in each inverter are exactly the same. All the voltages, all the parameters, all of it. So now I think I can turn on these circuit breakers. And hopefully nothing is blown up. So it looks like all of them are putting out 60 hertz. So now that all of them are working, I can turn on the auto transformer. That should be this one. I can hear a little buzz coming from the auto transformer. Okay, now let's go ahead and turn on this one, which will be the water heater. And all the fans kicked on. And it looks like this one is showing a little over 30%, and the other two are just under 30%. All right, we can turn that off. Next, let's see what happens when we turn on the solar, and that's going to be these disconnects down here. So this disconnect I'm going to switch on, and what happens? Oh, it's showing the solar coming in. So this one turned on okay. Let's see what happens. Now it says that it is charging at 0.7 amps. Okay. Now let's try the next one. Okay, so it found the solar, and it's going to drop that. That's open circuit voltage, so it's going to drop that down. I turned off the grid power. Now let's switch on the inverters. Let's see. It worked! Excellent. Well, this says we're pulling 1.1 kilowatts. I just came in the garage and I checked over here, as I tend to do, and the auto transformer is 48.2 degrees Celsius inside. So that's the hottest I've ever felt it. So I can feel that warmth. It's not like it's going to burn my hand, but I can feel it warm around here. Now it doesn't have a specification for the maximum temperature inside. However, it does say on here ambient air temperature 60 degrees Celsius. And if we look over here, we can see there's a whole lot of power being drawn on this leg compared to that one. So let's take a look at our neutral. So we're at 14 amps on the neutral. And so we're still half of what it can go up to. So it can go a lot higher than that. 32 amps on the neutral is the maximum. So I don't think this is bad in any way. I just noticed that it hasn't been that warm before, up at 48 degrees Celsius. I typically see it in the 30s. Each one of these inverters is $900, and it's a 5,000 watt inverter and can accept up to 6,000 watts of PV. Now the largest PV array I have outside is 5.1 kilowatts. So that entire array can feed into just one. This is the 5.1 kilowatt array feeding this inverter. This one is a 4.4 kilowatt array, and over here, this one gets a 3.3 kilowatt array. So this one has the easiest time. But all three have turned on and work at taking the power from the PV, charging the battery, powering the house and garage. I mean, they're doing their job. So just in the initial day here that I've had them on, there hasn't been any problems, and I'm really excited about it. I'll probably do a 1-month update after these have been running for a while to report if there's been any problems. During that time, I plan on running some efficiency numbers at different wattage, so at a high wattage, a low wattage, and try to find out what the overall efficiency is of running these inverters. They're a little bit less efficient than the SMAs, but there's so much less money that losing out on a little bit of efficiency might be worth it. But I do need to run the numbers to make sure. All of this is really sloppy. You know, I don't like the look of all of the wiring just out in the open, but I did want to get these up on the wall and test them. It's been a while waiting for parts to come in. If any of you have ordered things this year, you know it's just kind of difficult to get your materials and supplies in. So I wanted to get them up on the wall so I could get the testing underway, be able to make the videos for you. Now on a previous video, a lot of people commented that the way that I wired up the auto transformer could potentially be a little dangerous. Basically, I have the auto transformer on its own circuit breaker. Now the potential problem is if that circuit breaker trips for any reason and the house and garage are still pulling power, there will be an imbalance somewhere between the two legs. So the two legs have to add up to 240 volts because that's what they're putting out. But if you're not using much power on one and you are on the other, then there will be an imbalance, a difference in voltage between the two sides. So that was a great point that so many of you brought up in one of my previous videos, and thank you for that. I did order some parts to try to change that up and make that more stable. So once those parts come in, I'll probably change up and add the fusing to the PV wiring. I'll change up the wiring on the auto transformer, try to fancy that up and make it so that there's not the potential of feeding the house with an imbalance. So, you know, thank you guys for those comments. I do read all the comments and they are very helpful and I take them to heart, and I love that you guys take the time to try to help me out so we all just get better as a community building our DIY systems. Now, if you want to buy any of these components, I will leave links in the description below to Signature Solar, and you can use my coupon code, which is DavidPause, and that will get you a discount on your purchase. It is part of the affiliate program, so it does help out me and the channel. So thank you if you choose to use that code. So thanks everybody so much for watching. If you enjoy the videos, please like, subscribe, comment, and share.